Okay, this time I'm going to do solve by elimination, eliminate a variable by addition or subtraction, but this time I'm going to have to also do some multiplication with multiply. Great English. Okay, so when I did it without having to multiply, it was because my variables matched up. Now they don't. Okay, I have a 3 and a 1 and a 2 and a 1. So neither the x coefficient nor the y coefficient have matching numbers. So what I can do is multiply one equation, both sides, by any number I want. I could use 0. 0 wouldn't make much sense, and it wouldn't help. I can pick any other number I want. And I probably want to pick an integer so that I can just multiply one equation and match it up with the other one. What I want to do, my goal is to get this coefficient to match this one, or, and it really doesn't matter which you pick, that to match that one. I could do either one in this case. So I could multiply the bottom equation by either 3, so that I get 3x plus 3y, and I get my x's matching, or I could multiply the bottom equation by 2. Really doesn't matter. So I've got that there. Let's go ahead with that. So I've got 2 times x is 2x. I've got 2 times y is 2y. And I've got 2 times 7 is 14. This is often forgotten by many students, multiplying the other side. Some students forget to multiply both things here, right? You multiply the whole side of both equations. So now I've got 2 equations, these 2 that I'm going to work with. I'm not going to work with this middle one anymore. This one is out of the picture. So I'm not even going to worry about it. Right? Now I've got this top equation. I'll just call it equation 1 and equation 2. I'm going to subtract equation 2 from equation 1 because my coefficients match numbers, but they also match signs. Okay? And when that happens, I have to subtract to eliminate. Right? If I subtract a number from itself, I get 0. So if I subtract 3 from 3, I get 0, or 2 from 2. In this case, I'm going to subtract 2. So I'm going to subtract the second equation from the first. I'm going to subtract the 14. 19 minus 14 is 5. 2y minus 2y is 0. Leave it. 3x minus 2x is just x. And so this was a rather simple case, and you may notice I have the same solutions if you watched the other video that I had for that video. And so now I've got x equals 5, and I'm going to substitute in. What I don't want to do is use this equation. I don't want to do that because if I made a mistake, then I'm going to repeat my mistake and I won't catch it. So I'm going to use my original equation, 3x plus 2y equals 19, and I've got a 5, so 3 times 5 plus 2y equals 19, right? 15 plus 2y equals 19. 2y, I'm going to subtract 15 from both sides, and so I'm going to get 2y equals 4, y equals 2. So I get 2. I can check that in my original equation. My original second equation was x plus y equals 7. And I've got 5 and 2. 5 plus 2 equals 7. So it checks out. So that's how I do it with addition or subtraction, having to multiply one equation. I might have to multiply both equations in order to get them to match up, but it's the same process. I'm just doing it twice. So I'll give you a quick example before I end. I might have an equation like 3x plus 4y equals 10, and 5x plus 3y equals 13. Okay, and so you're going to notice here that these don't match and these don't match, right? And the problem is there's not an easy number. There is a number, but there's not an easy number that I can pick to multiply 5 by so that it becomes 3, or 3 by so it becomes 5. I could multiply 3 by a number and get 5. Okay, I could multiply 4 by a number and get 3, or 3 by a number and get 4, but it's a decimal or a fractional number. And so I don't want to mess with that. It actually turns out to be easier, really, I think, to multiply both. The trick here is it really doesn't matter what variable you decide to eliminate. So I can use x's or y's, and since I already know I'm going to multiply both equations, I might as well just pick x's. I need a common number. Well, if I multiply 3 times 5, I get 15. And I already know 3 is a factor of 15 and 5 is. Obviously, I use those two numbers to multiply together. So what I'm going to do is take the 3 and multiply by 5. So that whole side and that, don't forget both sides, and I'm going to take the 5x and multiply by 3. In other words, I just switch. Notice, down there, and multiply both sides by 3. And so now I'm going to get 5 times 3 is 15x, 5 times 4y is 20y, and 5 times 10 is 50. 3 times 5x is 15x, 3 times 3y is 9y, and 3 times 13 is 39. And now I'm ready to go because I've got my match. I could have multiplied both equations if I wanted by top equation by 3, bottom equation by 4, and eliminated y's instead of x's. Really doesn't matter. You pick.